Hello, welcome. We are looking at choosing the best method in 6.5, whether you should be using graphing, substitution, or elimination. Graphing is almost never chosen unless you're told to do graphing, because most of the time these are not easily graphed. There could be an exception though. So most of the time we're looking at how to choose between substitution and elimination for the best method. Not necessarily the one you prefer doing, but the best one. You can sometimes do one your way you'd prefer, even if it's harder. You're welcome to do that almost all the time. But let's look at which way is usually the best method or the quickest method to have less chance for errors in it. Let's take a look at the first one over here. The key on most of these is that if you have a variable that's by itself, that means substitution is almost always the best way to do it. What I mean by itself is that the coefficient of it is a 1. That means that you could easily move the other variable term to the other side of that equation. And now you know what x is. That's the same x as here, which means we can substitute it for that x. So over here I will do 2, and instead of this x, we will put what the x is in terms of y. Negative 3y minus 6 minus y equals 9. And then we would proceed to do the work of multiplying it out and combining the like terms and solving for y, and we would get y equals something, and we put it back in and figure out what the x is, and we would have our answer. So that means that for this one, substitution is the best method. Substitution is the best method here. Okay. It's true that this one could be done by elimination by multiplying the bottom equation by a negative 2 and then just adding them. That is true, but this one's already set up for you to easily get the x by itself and then substitute that, the result for that, into the other equation. This one here, neither the x nor the y have a coefficient of 1, so it's definitely going to be elimination. You could take, say, this first one and divide everything by 2, and then you could have one with y. So that could be said that substitution would be okay to do. But it's set up for you to just simply subtract these two equations. And these would go away, and you would get minus minus, you'd get a 5y, and you would get 10, and you solve y for 2 and plug it in to get the x. So just simply at the beginning, you can eliminate the x's by subtracting. So that means elimination is the best one for this. Now on the next one, this one's already set up over here, already set up where you just simply can add them together, and that means elimination is the best one for this. Elimination. On the one after it, we see y equals and y equals. So since y equals y, we can say that this one for the first y replaces y, or substitutes for it, and then this substitutes for the other y, 5 over 7x plus 8. Multiply everything by 7, combine the like terms, and you know what x is. So that makes this one that substitution is the best method. You are substituting the other side of these equations both for y in y equals y. You could also do this by, say, subtracting this one with minus 0 equals whatever the other stuff is, but now you got fractions to deal with here. So although it's possible, it's actually really much harder to do that way. So substitution is much easier in that method. Okay, now let's look at some others here. These next two, these ones show where you could do a number of options, say on this one here. But even though we could get the y by itself by subtracting 2x and then multiplying or dividing by negative 1, this one's pretty much already set up for you to just multiply everything by 3 and you'd get the negative 3y here, and adding them, you'd cancel them out. So again, this one is better done by elimination. Now, someone could argue that it's really faster even than to do it by substitution, by moving things around. That's possible, but I don't think so personally. And so I think we stick to the rule that if you have the variable by itself, it's usually easier to, or if the coefficient should be 1, and this time it's a negative 1. And that adds a little bit of a layer of complexity. So you could argue substitution, you could argue elimination, but I'm going with elimination. That's the better answer here. Over here on this one, now we've got some good choices. I think in this case, I look at it and I would just simply subtract and get rid of the y's. So elimination, right there in one step, you've gotten rid of the y's. If you don't do that, you can change this one to y equals negative 4x plus 12, and then put this in for the other y, or you could paint both of them to y equals negative 2x plus 2 and have these two equal to each other. You know what? It would have been just easier just to subtract right at the beginning, and we get a 2x, y minus y equals to 10, x equals 5, and then we keep on going. So again, elimination is the best method. Now back for a moment to this one here. Those are set up as y equals mx plus b, so you could probably pretty easily graph this one. So when it's y equals and y equals, substitution or graphing could both be considered a good one for this, because these are easily set up right now to do it. I still think substitution is the easier method, because even in graphing, you then have to determine where that point is, where they meet. But graphing would be acceptable if they're both already y equals on it here, and this one and this one. Okay, even on this one here, I didn't really keep on numbering, so I should number them. I'll call this one 2, 3, 4, 5, and 6. So for number 6, you could change them to y equals mx plus b, but this was still easier over here. So elimination is the better answer for that one. There are 4 others to look at. Why don't you take some time right now to try to do these yourself? I will pause the camera. Actually, I'll just say you pause the camera or the video. Do them for a few moments and then come back, or just simply decide, should it be substitution, elimination, or graphing? All right, go and do it. Okay, you are back, and now let's go over these. This one, clearly, this would be number 7 here. There is no, all the coefficients are anything but 1, so this is elimination. Elimination. And on the next one, up here we have an x equals, so we would just move the things over. This would become x equals negative 3y minus negative 3y minus 6, and then we plug that in over here. So in this case, substitution is better, simply because the coefficient of one of the variables is a 1. That's the clue we're looking for then that makes a substitution. This one here, same thing. This could be substitution. We just simply take this and we just put it inside that. We'd end up with a 4 as a denominator. Multiply everything by 4, and that's done and taken care of. So this one again is a substitution. And on this one, none of the coefficients are 1, so therefore this is an elimination. I hope that helps you, and having seen that now, the next parts of 6.5 will be under the videos, so please go look at those, and have a good night.